Hello everyone. So in this video, we'll be looking at one of the two ways in which regular expressions and languages are tied together. So these two ways are, like I said in a previous video, the way that regular expressions and languages map from one to each other. So if you have the family of regular expressions and the family of, we'll see soon, regular languages, then these regular expressions here, R1, R2, and so on, they map to particular languages. Okay, we'll see in future videos why this is actually the family of regular languages. But in this example, we'll be going through some of the steps that I presented here when I described how we can extract the language described by a regular expression. So we have the following regular expression R here, and we want to determine what L of R is. Okay, so essentially what we're just going to be doing is we're going to be applying a sequence of these regular expression to language steps recursively. Okay, so we're going to apply it to the large expression, then we're going to apply it to sub expressions, and so on until we get primitives, and then we're going to build back the language from these primitives. Okay, so how do we actually do that? Well, we start with applying L to L of something to R, right? So you can think of this as an operator, right? Right. So for our purposes in this example, you can kind of have this intuition that when you have R, you can augment R with this L of operator, okay? And what this does is that it takes the regular expression and then it maps it, okay, to a language, okay? So we apply this operator to the regular expression, okay? Now we use the first or the second of the rules of extracting the language represented by a regular expression, where in this first situation, we have the concatenation of this regular expression, so this is R1, and this regular expression, so this is R2. If this is R1, we have R1 concat R2, and so from L of R1 concat R2, we get L of R1 concat L of R2, and now this is a language operation, okay? Now again, we apply the same idea. This time, for this regular expression, we apply the plus conversion to the union, right? So we have L of R1 plus R2 gets converted to L of R1 union L of R2, okay? And then in this case here, we take L of star, and this becomes applying the star operation to L of R, right? Then we could actually take this even further. From this line to this line, I actually skip some steps. Really what's going on, for instance, for L, A, B, right? This is actually A concat B, which is LA concat LB, and this is the language containing A concat the language containing B, so this is now a language operation. So now we can use the definition of language operations to get the resulting language AB, okay? But for subsequent videos, when we have L of AB, we're going to directly map this to the language containing AB, okay? And so similarly, if we have a much larger regular expression, we're going to map that directly to something that looks like this. Okay, and so the same kind of logic, the same kind of steps here are applied for L of BB and L of A, right? So in this case, we get the set containing A. In this case, we get the set containing BB, right? So now we have the language containing A and BB, and it's going to be concatenated. So now we have a language concatenation with AB star, right? And so remember, this is now star operation on the language containing just AB. So remember what AB star is, okay? If we just use the star, the definition of the star operator, that's you take AB0 union AB1 union AB2 union and so on, right? So AB0, any language 0 is just the language containing the empty string, then union AB, then union. So here this is AB concat AB. So because each of these two languages have a single element, it's just this string concat this string, right? So it's AB, AB, union, AB, 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 and so on, right? So as a matter of fact, it's actually just AB to the n for n greater or equal to 0, right? Because we defined a string to the 0 as the empty string in previous videos. And so this language has been rewritten as this, right? So now I just take this guy and I concatenate it with these two languages. So at this point, you could probably already call it quits and be done, right? So this is probably good enough. But if you want to expand it a bit further, just to get things really clear, to really see what exactly the strings that belong to the language denoted by the regular expression are, well, we can see that it's A and then concat with any string in here. So it's an A followed by any number of ABs, or it's BB followed by any number of ABs, right? So these two could probably be acceptable answers, right? And so now what this means is that this regular expression R, right, denotes, okay, this language L, right? So this language, let's call this L, denotes L. And so you can already see that if you were to try to create a DFA for this language, you would be able to do so, right? And so it so happens that in this case, R maps to a language L, where L can actually be accepted by some DFA M. So there is some DFA, there exists some DFA M that accepts L. I'll let you do this as an exercise. As an exercise, try to build a DFA M such that L of M is equal to L, where L is this guy. Okay, so once you solve that exercise, you'll have created a machine M that accepts this language L. And at the same time, we see that we have this regular expression R that denotes a regular language, in fact. And so we'll see in future videos how regular expressions and regular languages are related.